Yeah, today we'll see the analysis of this combination circuits. So how to analyze the circuit. Just I'll give a brief intro of this. So how to do the analysis part. So next we'll see the designing part. So designing in the sense already we have seen that designing using code converters and all those things. So what we'll do here is we'll take few examples, two examples in the design. So I'll just give you the problem. So what you have to do here is you have to understand the problem and draw the truth table. Okay, and after drawing the truth table, and have to use the K maps for finding the output equations, and you have to draw the diagram. So just as usual. Okay, so that is what we are going to do right now. So first of all, we'll see the analysis part. So analysis is already a circuit diagram will be given like this. Okay, and what we have to do here is and draw the truth table. Okay, so that is what we have to do here is. So that is the analysis part. So wait a minute. So 1 minute. Hmm, 1 minute. So I need a pen here. Yeah. Right. So this is how to analyze this circuit here. So you can see here. So this is one gate here. Okay. This is another gate. So this is AND gate. This is a OR gate, and this is another OR gate, and this is AND gate and inverter. So what we have to do here is we have to find F1 and we have to find F2. Okay. So here F1 come to the back tracing here. So addition of these two. Okay. So addition of these two in the sense. So T2 plus T1. Okay, so T2 plus sorry, so we have T3 also here. Okay, so it is nothing but addition of T2 plus T3. So F1 is equal to when we come to the back tracing here, it is T2 plus T3. What is again T3 here? So T3 is equal to, it is ABC, A plus B plus C. So A plus B plus C. Okay, so into F2 bar. Okay, so this is how we have to do here. And coming to this T2 here, so T2 is equal to A into B into C. Okay, and coming to this F2 here, so what is F2? F2 is nothing but AB plus AC, AB plus AC plus BC. So that is F2. So straight away we'll get the values of F2 here. So AB plus AC plus BC. Okay, so this is the analysis how we have to do here. So analysis in the sense a circuit diagram will be given and you have to find the equations, output equations F1 F2 here, and the F1 F2 are the equations like this. Okay, you can check here. Right, so draw the truth table for F1 F2. We have to find truth table here, and these are the equations. So the equations will be like this. Okay, so F2 is AB plus AC plus BC, and this is the value of T1, and this is the value of T2 here, and T3 is F2 bar T1, and F1 is T3 plus T2 here. So substitute these values, we'll get these values. Okay, and after substituting the values, what we have to do? So we have to draw the truth table here. So truth table will be like this. So A, B, C are the inputs, and these are the outputs here. So the wanted outputs are F1, F2. So whereas these are the internal inputs here. Okay, so which will make the F1 and F2 here. Yeah, getting my point. So analysis part, okay. So you will be given analyze the circuit in the sense. So what you have to find is you have to find the equations, output equations from the circuit diagram. Okay. So afterwards, so draw the truth table. So we can see here the outputs, the inputs are A, B, C here. So A, B, C are the inputs, and we'll be having outputs of F1 and F2. Clear?
Yeah, sir.
Okay, so analysis is nothing but analyzing the circuit, so analyzing the logical circuit here. Okay, so that is the analysis part. Okay, and coming to the design here, so I'll be giving one problem. So what we have to do, we have, based on the problem, first of all identify the inputs and outputs and draw the truth table, and from the truth table, so find the output equations. Okay, and after finding the output equations, so minimize the output equations with the help of the K maps, and finally draw the logic diagram. Okay, so take down the problem here. So problem is, so design a circuit with 4 inputs and 1 output, where output is 1 if the input is divisible, if the input is divisible by 3 or 7. Okay, so there is a problem statement. So we have to design a circuit in such a way that, so it should have 4 inputs. Okay, so it should have 4 inputs here. Okay, and 1 output. So this output is equal to 1. So whenever the inputs what we have, so 4 inputs and 0 to 15 ఉంటుంది. So out of this 15 inputs, the inputs which are divisible by 3 or 7, so that output will be equal to 1, and remaining outputs all equal to zeros here. So that is a problem statement. Okay, so that is the problem statement, is one here. So first of all, give the 4 inputs here. So inputs, and we have outputs. So inputs A comma B comma C comma D, outputs, that is Y. Okay, so 0 0. So 4 input, right? So we'll be having 16 possible combinations. 0 0. At the 16 possible combinations. So these are the 16 possible combinations. So 4 inputs. The output is 1 for the inputs, so which are divisible by 3 or 7. So identify the inputs which are divisible by 3 or 7. As usual, so like 3. So 3 is divisible by 7. Okay, and 6 is divisible by 7. 4 5 6 is divisible by 7. Okay, and 7 is divisible by 7. So 60 is divisible by 3. So 7 is divisible by this value. So 6 is divisible by 3. This is divisible by 3. This is divisible by 7. And 9 is divisible by 3. And 12 is divisible by 3. 14 is divisible by 7. So these are all ones, and the remaining all are zeros here. Okay, so that is the problem statement we have to understand. Okay, so the first one is 0, and the second one is 0. It is 0. This is 1, 0, 0, 1, 1, 0, 1. Next 0. So this is for 0, 1, 2, 3 is 1, 4, 5, 6 is 1, 7 is 1, 8, 9 is 1, 10, 11 to 12 is 1, 13 it should be 0, 14 is 1, and 15 should be 1. Yeah, because it is divisible by 3.
3, sir.
Yeah. So this is the outputs what we get here. Okay. So this is output what we get based on our problem statement. Okay. So now, so we have to draw the K map for Y here. So Y K map. So K map for Y. 1, 2. So draw the K map. This is AB. This is CD. 0, 0, 0, 1. So 1, 0, 1, 1, 0, 0, 0, 1. So 1, 0, 1, 1. So what are the outputs 1 year? So for the midterms,
3, sir.
yeah, 0 to 3. So 3, uh, so this is
6, 6,
4,
7.
5, 6, 7. So 6, 7. So these are 1. And again, it is
9.
8, 9. So 10, 11, 12. So 12 is by 1.
14,
13,
15.
14, 15. So these are equal to the ones here. Okay. So now we can form a quad here. This is one quad. Okay. So what is this value here? So what is this value? So row term. So these two row terms here. So a bar b plus ab here. So a plus a bar, b common they say, a plus a bar. So we'll get a b here. So b into, so column term. So these two columns.
C,
Uh,
sir.
so this is C.
C, sir. C.
Yeah, it is BC. Okay, and next terms, what are the next terms here? So we can form a pair here. Okay, so we can form a pair. So what is this value here? So row terms. So these two rows are compared here. Okay, so these two rows
A,
are
C, D,
compared. A bar. Okay, and this is
A bar
the
CD.
column here. So A bar
C,
CD.
D, sir.
CD.
Yeah, so BC plus A bar CD. Okay, and we have another pair here. We can form another pair. You can check here. So this one,
12 and 14,
yeah,
sir.
14. So this is forming another pair. Okay, so when we form this pair, so what is this row term here? So row term is AB.
A,
So
B,
what?
D bar, sir.
So these two are compared. So these two are compared.
AB D bar, sir.
So it is nothing but D bar, AB, D bar, and we are left with one term here. So that one term is a single literal. Okay, so that one term is a single literal. So that is, so row term is, what is row term here? A,
A, B bar.
A, B bar, and what is the column term here?
C bar, D.
C bar D.
C bar, D. Okay, so this is the final thing here. So it is AB, sorry, BC plus ABD bar, A bar CD plus AB bar C bar D. Okay, so just draw the circuit diagram. Just draw a circuit diagram. So we have A, so B, C, D. So this is a normal general method. I mean, which you find it easy. So I'll prefer this method. Or else you can directly draw this. So on the method, you can directly draw like this also. So first, what is this one here? So we have B and C are given to AND gate. So four product terms, four AND gates. Okay, and A bar CD. So that is A bar. So you can draw like this also. So whichever case is not a problem here. Okay, so but that is a general method. You can follow that method. So this is second
AB
one here.
B bar, sir.
So next A,
B
B,
G bar.
bar. So which are given to these are product terms. So hence give it to AND gate. Okay, and the last one is what is the last one? A, B bar, C bar, D. So we have A, B bar, C bar, D bar, right? C bar, D bar, or C D bar? C bar D, yeah. It's not D bar. Okay, so all these four are given to an AND gate. Okay, and all these four are given to so OR gate. Okay, so this is how we will identify the problem. Okay, and so we'll draw the circuit diagram. Clear?
Yeah, sir.
Yeah. So we'll take one more problem of this kind. Okay, we'll take one more problem of this kind. So I have to understand the problem and draw the truth table. So design a combination circuit. So take on this problem. First of all, understanding is important. Design a combinational circuit with three inputs x comma y comma z and three outputs capital A comma B comma C. Okay, so there's the first case here. The conditions are like this. When the binary input is 0 comma 1 comma 2 comma or 3, the binary output is 2 greater than the input. Okay, so when the binary input is 4 comma 5 comma 6 comma 7, the binary output is 2 less than input. Okay, so there is a problem given here. So x, y, z are the inputs here, and ABC are the outputs here. So, but here given two cases here. So when the inputs are 0, 1, 2, 3, so it should be 2 plus the given input. So when the inputs are 4, 5, 6, 7, it is 2 minus the given inputs. Okay, so simple problem here. So truth table will be like this. So inputs, outputs. So inputs are small x, y, z. Outputs are A comma B comma C. So input, first of all write the input combinations. So 0 0 0 0 0 1 0 1 0 0 1 1. Okay, so check the binary inputs here. So inputs 0 1 2 3 it should be a plus of the present input. So it is 0, hence it is 0 plus 2, it's 2. So output is 0 1 0. Okay. And the second case is 1 plus, so 1 plus 2, it's 3.
0 1 1.
Yeah, 0 1 1. And the next case is, so 1 double 0. Okay, and for 3 it is 1 0 1. So for this 4 inputs it should be plus 2, and from 4 to 7 it is minus 2. So 1 0 0 minus 2, so we'll get 0 1 0, and 5 minus 2 it is 0 1 1, and 6 minus 2 it is 4, that is 1 double 0. 7 minus 2 it is 5, that is 1 0 1. Okay, so there is the truth table, I mean what we got here. So next we'll go for the k maps here. So it is k map for a b c. Okay, so we'll find the k map for a b c here. This is a b c 0 1 0 0 0 1 1 0 1 1. So what are the inputs for a? For a, this is for a here. So a is equal to, for like 0 1 gakunda, so 0 1 2 3. Okay, so for 2 3 it is equal to 1
6
6 7.
7.
Okay, so we'll form a quad here. So the value is equal to, so what is the quad here? So it is equal to, a is equal to, sorry, it is xy, right? Sorry, so it should be in terms of inputs here. Okay, this is small x yz. Okay, so the value is equal to, so compare these two rows here. So to call these two columns, so it is yz plus yz bar. So if I take y as common, z bar, z plus z bar is equal to 1 here. So a is equal to y. Okay, so a is equal to y here. And second case is for
Sir,
b.
someone are waiting to join, sir.
So for b here, so this is x y z 0 1 0 0 0 1, so 1 0, so 1 1. And this is for b here. So b for 0 1
0 1 4 5, sir.
4 5. This is 4 and this is 5. Okay, so this is formed as another quad here. So b is equal to, so this is y bar z plus y bar z bar plus y bar z. So b is equal to y bar. Okay, in a similar way, so we can go for another term, that is x. So y is it 0 1 0 0. Okay, and the terms are,
1 3 5 7, sir.
so 1 3 5 and 7. So this will form another quad here. Okay, so the equations is quite simple. So c is equal to z.
Z, sir.
Okay, So just the circuit diagram name undadu, just the values will be like this. So y, this is equal to a, and y bar, so use an inverter, so this will be equal to b, and z, so this is equal to c. Okay, so this is how the problems will be generally. So the problems will be very lengthy, but you may get a simple solution for this. Okay, so take down another problem. Take down another problem. Design a combination circuit. So this is your exercise problems. Most of the problems are of your exercise problems, so which are after your textbook. So after the completion of the unit, you'll find these problems. Design a combinational circuit that generates the nines complement and tens complement of a BC digit. Okay, so BCD values are from 0 to 9. Okay, so you know that, right? So BCD values are from 0 to 9. So one circuit should find the nines complement of the given BCD, and other circuit should find the tens complement of the given BCD. Okay, so we have to design two circuits here. So one will generate the nines complement, other will generate the tens complement. Okay, so we'll assume that, so inputs are, so BCD values from 0 to 9, so we need 4 inputs here. Inputs are so capital A comma B comma C comma D. Okay, and so nines complement outputs will be taken as output. I'll take it as WXYZ, small w. I'll take it as WX comma Y comma Z, and tens complement output, I'll take it as PQRS. Okay, so these are the inputs and these are the outputs. So the truth table is the important one. So nines complement is nothing but, so subtract the input from all nines. Like if it is like 0 0 0 0, 9 minus 0, so it's 9. So 1, it's 9 minus 1, it's 8. So tens complement is nothing but nines complement plus 1. Okay, so nines complement plus 1 will give the tens complement. So first of all, write A, B, C, D inputs. So input combination from 0 to 9, because it is a BCD value. Above 9, it is taken as don't cares. So these are the inputs. Eight, and this is 9. Remaining all are unused combinations. Okay. These are the inputs and outputs. So outputs for nines complement here. So the first one is for nines complement. So W, X, Y, Z. Tens complement outputs. That is PQRS. So PQ R, S. Okay, and so 9's complement outputs will be like this. Okay, so 0, 8 minus 0, it is 9. So 1, 0, 0, 1. So 9's complement, when we'll get 9's complement is like 9 minus the total values, total input here. So we'll get the 9's complement. So 9 minus 1, it is 8. So 1, 0, 0, 0. Okay, and 9 minus 2, it's 7. And so 9 minus 3, it's 6. 9 minus 4, it's 5. 9 minus 5, it's 4. 9 minus 3, it's 6. Sorry, 9 minus 6, it's 3. 0, 1. And 9 minus 7, it's 2. 9 minus 8, it's 1. 0, 1. 9 minus 1, it's 9 minus 9, it's 0. Okay, so this is the 9th complement of BCD values. Okay, and you find the 10th complement, just add 1 to the 9th complement, we'll get the 10th complement. So 10th complement. So 1, 0, 0, 1. So it is like 1, 0, 1, 0. Next 8 plus 1, it's 9. So 1, 0, 0, 1. So the 7 plus 1, it's 8. Okay. And 6 plus 1, it's 7. Similar way, fill all those things. And the last one is just add 1 to the 9th complement. 0, 0, 0, 1. And 0, 0, 1, 0. So what we have to do here is, so 9th complement circuit. So how can we generate 9th complement circuit? Just find the equations for W, X, Y, Z. So find the equations for W, X, Y, Z. I'll show 2 of them. So I'll show the 9th complement. You can do the 10th complements one. Okay. So this is inputs, right? So A, B, C, D. I'm finding equation for W now. So 0, 0, 0, 1. So 1, 0, 1, 1, 0, 0, 0, 1. So 1, 0, 1, 1. So at W it is like for 0, 1 it's 1 and remaining things are don't guess here. So remaining things are zeros. Okay. So 0, 1. And we have don't case from 9 to 15. So this is, sorry, 10 to 15. 8, 9, this is 10, 11, 12, 13, 14, 15. Okay, so we will use don't case only whenever there is grouping with 1. So here there is no need of grouping the don't case here. Just only the term that is possible is W here. So W will be equal to, this is this row term A bar, B bar, In the column term, so this grouping of these two, A bar, B bar, C bar. Clear? Yes or no? There are. It's okay. So this is the 9's complement one. Okay, and this is W is equal to A bar, B bar, C bar. Next, we'll see for Y. So we'll see for Y 0 0 0 1. So 1 0 1 1. Okay, so Y for Y it is 0 1 2 3 is 1, and 4 5 it's 1. Okay, and remaining, so 9 10 11 13 14 15 are don't gets. Okay, so we can form a quadia, we can form another quadia, so this one and this one. Okay, so this is the value of x here, so x is equal to, so these two, what we'll get here is it's b into, so this one c bar, and these two rows. Okay, so we'll get so b bar c. Okay, so x is equal to, so b exclusive of c. Okay, so this is the case with x here. Okay, so w is equal to a bar b bar c bar, and x is equal to b exclusive of c. Okay, and next coming to y here. So y, you can check the y here. So we have 2 3. Okay, and we have 2 3, and this one. So what is this one here? 0 1 2 3 4 5 6 7 6 7. So this is 6 7. Okay, and we had one case from 8 9 10 11 12 13 14 15. Okay, so this can form an octet. Okay, so now I'm forming octet, so grouping these two, so this is y value, so y is equal to c. Okay, so the value of y is equal to c. Next, so coming to z, we have 0. Okay, and 0 1. So these values, so check the z value here. Mm, 0 1 2. Yeah, this is 0, this is 1, and this is 2. Okay, and there is no 3, we have 4 and 7. Okay, and the other value is 8. For 8 it's equal to 1, and we have two kids here. Okay, so this 4 and this 4 can form an octet. Okay, so when I group these two, so I'll get a d bar here, so z is equal to d bar. Okay, so the equations are like this, so z is equal to d bar, so y is equal to c. Okay, and we have so x is equal to b exclusive of c, and w is equal to a bar b bar c bar. So these are the equations, and you have to draw the circuit diagram. Okay, so draw the circuit diagram for this. So the equations will be like this: a b a b c d. The complements take if possible. B, C, and this is D bar. Okay, so the first one is, so we can check y is equal to C. So, or if I want to take W here, so W is A bar, B bar, C bar. So this is A bar, B bar, C bar, so which is given to AND gate is W. Okay, so X is equal to B exclusive of C. So we have B here, we have C here, give it to an exclusive OR gate. This is X. Okay, and so Y is equal to C. So this is Y. Okay, and Z is equal to D bar. This is D bar here. This is Z. Okay, this is all I have to do. And so coming to tens complement, so go with the similar method. So find the equations for PQRS. Okay, so find the equations for PQRS and do the same things. Clear? Right. So this is the class for today. So this is the design part. So you'll be given the problems like this. You have to design the combination circuits. If you are given the analyze the circuits here, you'll be given the circuits here. Okay. So circuits will be given. So circuits ichin tarvata, so you have to analyze that circuit there. Okay. So next class we'll see the remaining leftover topics. So we have some multiplier, comparator, and decimal adder. So with this we'll finish the half of the unit. Okay, so we'll finish that specific half of the unit, and we'll go for the PLA part. So we'll see that PLA part, and flip flops and all those things we'll see in the next part. Okay, so by tomorrow we'll finish the half of the unit of this combination circuits. So we are done with this combination circuits by tomorrow. Okay, so drop your attendance and can leave.